All right, so let's get started. I think I know almost everyone here, but Josh, okay, all right, there. All right, so welcome back. Um, so this semester, I think, as I mentioned in the email, we are doing pretty much everything the same as what we did last semester. Okay, so since you guys are in the Wednesdays lab section, so then we meet in person here for the lecture, and if you are on Friday's section, then for the lab, then you meet in class in lecture on Friday. Okay, then we can on Monday we all meet online. So that's the same setup as we did last time. So on the Moodle page over here, I put up the Zoom link if you have to join online, and then the course syllabus over here, office hour over here. So this is my schedule actually, but it has my office hours in there too. Okay, and if you click on the first PowerPoint here, it will direct you over here actually. I already clicked on that one, so I'll just bring this up over here. And then the first thing we are going to do today is quickly going through the course syllabus over here. If you click on here, then a link will pop up that will direct you to this document over here. Okay. So again, my information are listed over here. All right, and we meet on Wednesday, Monday, Wednesday, Fridays, 9:10 to 10:10 for the lectures. For the lab, you are either in the Wednesday lab section or on a Friday lab section, still in this room. Okay. This is my office again here, my phone number, email address over here, and then the office hour. It's over here. If you click on this one, it should give you my schedule here. So on Monday afternoons, I'm free, so you can join me for the office hour if you have questions. On Tuesdays, there's this 9:10 hour, I'll be free, and then on Thursday too. Okay, on Thursday, there's this hour 11:30 to 12:30. I'm also available for office. Okay, since we are still in the pandemic, so for the office, we are preferred method to meet is still online. Okay, so this is a Zoom ID. It's down here. If you want to join me for office hour, if you have question. Okay, but just let me know if what time you want to meet so that I can prepare, because otherwise I might have other thing scheduled. For example, maybe at certain time I might have a couple of students want to meet me at the same time. So it's better that if you send me email in advance to inform you so that I can schedule that accordingly. Okay. Otherwise, you can always ask me questions before or after classes, or during like lab section, before or after lab sections. Okay, those are still available times for questions. Now, one thing that is different is this semester I'll be having all the physics lab sections, like the general physics and university physics as well. Okay, so from the labs, these two courses, they are the same labs. Okay, now there's slight difference in order of how labs are assigned to these two classes. Okay, but chances are if you missed say a Wednesday lab, you can come in as we did last time, like you can come in on a Friday section, or maybe on a Tuesday or Thursday. Okay, just let me know. For the first 3 labs, we are having all the same labs. Okay, so for the first 3 weeks, you can actually kind of have other options on Tuesdays and Thursdays. Okay, and then from the fourth arm, the order is slightly different. Okay, so on that one, you can kind of like maybe you are missing with a lab this week, you can make up it next week on a Tuesday or Thursday lab. Okay, in that um, setting over there. Okay, but let me know in advance. Okay. All right. So let's move on to back into the syllabus part here. So these are the informational items for disability services here, and then title 6, 7, and 9 compliance over there. Okay. Description of this class. So in this semester, we'll be focusing on thermodynamics, electricity, mechanism, and waves and optics. Okay, that's the focus this semester. All right. So again, information items for course objectives are here, list here. So the textbook is the same textbooks you are using last semester. Okay, it's from the openstacks.org. You can get a free e-copy, download the book to your desktop. Okay, so I think last semester we kind of went through from first chapter to chapter 12 and then chapter 15 in the textbook. Okay, so if you were not here last semester, you want to take a look on those chapters to see what was covered last semester. And then this semester we'll be doing like chapters 13, 14, and then 16, etc. I think until up to 26, chapter 26. Okay. All right. For the homework assignment, again, it's going to be from expert TA here. Now you have to register again, okay, for each semester. So this is a new link here. You can click on this link. It will ask you to provide your school email address again. Once you type it in, if you register already last time, then it will ask you to, if you want to keep it the password or set up a new password, okay? Or maybe I think it's, if you type in your email address, you will detect that it's already registered. You just need to put your password there and then going from that point on, okay? All right, and then the same here, you could have 2 weeks of free trials once you sign up, and then you can pay after 2 weeks to get the full access after that point, okay? All right. So topics here covered. So this is more in details, but it's basically electricity, magnetism, thermodynamics, waves, and optics. Okay. Okay. For attendancy, it's the same as we have had last semester. So basically, if you are sick, then you can join us online. For example, if you are supposed to be in seat, but if you don't feel well that day, just let me know, then you can join us online, okay? Then you will be marked as attended the class, okay? You will be marked as present in the class. Now there's details here like which absence are considered as the excuse, which are not, okay? So basically the same as we had before, like if you are sick, if you have like emergency, etc., other medical issues, then you are excused. Other things like if you just overslept, okay, that's not excused, okay? Or if you simply just don't feel like going to class, then that's not an excused absence, okay? So the same here, if you have more than 6 excused absences, then you'll be notified by the student for center success, okay? Warning you that you will be disenrolled from a class, okay, if you have more than 9 excused absence, okay? A couple of dates here, 26th January is the last day to drop the class, okay? And then March 12th is the last day to withdraw from the class, okay? Appeal process are also here. For the credit hour definition, so this is like this is a 4 credit hour class. Okay, so you are expected to spend about 8 hours a week for this class. Okay, 7 to 8 hours per week, and that is not including the class and lab time. Okay, so that's outside of class effort. Okay, all right. Homework assignments. Okay, so there will be homework assignments for the lecture and then also for the lab. So for the lab, it's the report. If you couldn't finish in time in lab section, then you'll finish after the lab section. Okay. Again, for the lab reports, so typically it's due 5 days after the lab section. So if you are on Wednesday section, then it's due on Monday next week. And if you are on Friday, then it's due on Wednesday next week. Okay. Now, again, because the pandemic situation here, you are free to leave if you have already collected your data. But let me take a look on your data before you leave, okay? So in case some data don't look good, okay? All right. And then for the lab, again, I prefer to have 2 people work as a group. But again, the situation is we have 13 students on Wednesday section. So there will be 1 group on Wednesday. We'll have 3 students work together. And then on Friday section, because there are 9 in Friday section, there will be, again, just 1 group have 3 people work together, okay? The rest will be like 2 people working as a group. And then, again, the same policy here, just 1 report for 1 group, okay? And that's should be shared with me through Google Drive. Now, I think last time, most of you guys are doing good on sharing that, but just in case, I think there's a couple of you guys still were not familiar with how to do that. Okay, so you go to Google Drive. I think everyone has a Google account. Then you should have a Google Drive there as well. If you don't, you can sign up for free. Okay, you can go there to create your lab report. You can, or you can make a folder somewhere here. So for example, I have a lot of folders here. I can create a folder under my drive. Say new folder. You can create a new folder. Say this is for example, physics 2. Okay. You can create that folder. Then you'll show up here. You can go in there. Now you can create, say, Google Docs for your report. Okay, so you can say lab 1 report. A lot of texts in the lab manual, you can copy them over here. For example, for the title and then objectives, etc. Okay, and then working on the reports over here. Then you want to share. Click on share. Give it a name. Say lab 1. Okay, and then save. And share with me. So the email address I have for my Google account is learn.mvnu.edu. Okay, so that's the one you want to do. Let me pick that one. Okay. You can also like set the permissions, like I can only comment on it. Okay, that would be better if you want, because I don't want to change your lab text, but just want to comment on it for the grading. Okay. Also, so this is the way you want to do the use the Google Doc for your lab report. If you are doing a Word file, what you need to do is drag the file into this folder here. Okay, drag your Word file into here. So yeah, just I think most of you guys know how to do it, but drag here and then you'll have the sharing option. Okay, just right click on here, you can share. Okay. Also for the Excel spreadsheet, a lot of times we use Excel spreadsheet for data analysis. You want to share that with me too, okay? So this is how we will be doing that. All right. Now for the exam, this is something I would like to make a change here for this semester. So I um, don't want to divide you guys into two groups anymore. We'll just have the exam at the same date, same time. Okay. So, but probably not in the same classroom. So there will be like two rooms. I will find another room maybe next door or somewhere. Okay, for both our group to have the exam together. Okay, because last time when we are doing one group on Monday and then the other group 2 days later, it kind of pushes the homework assignment days very tightly at the end of the semester. So then for the last two homework assignment, you basically only have 2 days for each. So that's something I didn't want to do anymore. But in that case, I can find a room, and then also I can find someone to proctor the other section. Okay, so I'll be proctoring one section, and then the other person will be doing proctoring for that section too. Okay, but when the date for the exam is near, then I will announce the location, and then for like which group go to the other room, which group stays in this room. Okay, so for the information later. All right, so I think that's the only change we will have for this semester, but otherwise everything else is the same. Okay, for the same credits here from each homework, from homework assignments, from lab reports and exams, they are the same. 20% will be credited to your homework problem assignments total, and then 20% from lab reports, and then 15% for each of the exams, okay, including the final exams, okay. And then the final grades will be assigned according to this table. It's the same table as we had last time, okay. All right, some references here if you are interested, and then the detail on how to register for expert TA is on the last page of the syllabus, okay. All right, any questions you guys might have? If you are online, I think default you are muted. If you want to speak up, you can unmute yourself, okay. All right. Also, I think for the lab schedules, I have tentative lab schedule assigned online. You can take a look to see which lab you are expected. Okay, but today, this week we do not have lab. Okay, so for the first week we do not have lab. The first lab starts from next week. Okay. All right. Anything I'm missing? I cannot think of anything if I'm missing, but we'll go to the lecture part here then. So we'll be starting from chapter 13. The first big topic we'll be covering this semester is thermodynamics, okay? And it's in chapter 13 and 14, all right? So the first homework assignment will be up today at some point, the first one, and then it's due Thursday next week, okay? So about 8 days from now. All right, and then again, for each class, for the in-seat section, I will have two students doing the disinfection after the class. So today is Abigail and Sarah, okay? And then I'll assign that each time. All right. So I think for the first part of the lecture, this is something you guys are very familiar with either in your daily life or in the other classes. So we'll be talking about temperature, okay? So usually we use a thermometer to measure temperature, and this is the old style thermometer. Now for these days, you guys pretty much have like digital ones, okay? So yeah, there's other older ones, older thermometers. So this might be something you can find in your like if you have old thermostat at home, you will see something like this, okay? And also there's something like this. We have dial here. For this guy, this is made of two, like in this spiral part over here, this is actually two strips of metal pieces stick together, okay? And then two of them are made of different materials. So when the temperature changes, either increases or decreases, then they either expand or shrink differently. So then you will kind of make a torque here, make this needle pointing at different scales for the temperature, okay? All right, in physics, so this is the formal definition of temperature in physics. It's defined as high value of something with hot object, okay? And then low value of it with cold object is called temperature, okay? So if the object is high, then the temperature will be high, okay? The object is cold, and then the temperature will be cold. Now, keep in mind the SI unit for temperature is Kelvin. It's K, okay? So I know we are using Fahrenheit here, okay? And then most of the rest of the world, they are using Celsius, okay? But either Fahrenheit or Celsius, they are not SI unit. The SI unit is Kelvin, K, okay? We'll talk about the conversion later a little bit. And these days, we are having like digital ones. We have this one at home for our kids, and they like to play it as a toy every day sometimes. But you can actually have different settings. Okay, if you travel to another country, then you can actually have different settings. Like you can change it to Celsius, okay, from Fahrenheit. Okay. All right. Now let's talk about the scales from different units here for temperature. So the Fahrenheit over here, 9 degree in Fahrenheit, the change of 9 degree in Fahrenheit is corresponding 5 degrees in Celsius, okay? So if there's a change of 9 degrees in Fahrenheit, that means 5 degree change in Fahrenheit, in Celsius. And then the same 5 degrees change in Kelvin, okay? So for Kelvin and Celsius, the scales are the same, okay? So 5 degree in change means 5 degrees in Kelvin, okay? But doesn't mean the absolute values are the same, okay? So this is the scale is referred to the change of it, okay? So in Fahrenheit, the boiling point for water is 212 degrees, and then in Celsius 100 degrees, in Kelvin, which is 373.15 degrees, okay? So this is from Celsius to Kelvin is a difference of 273.15. So if you want to get a temperature in Kelvin, you simply add 273.15 to the number in Celsius, okay? But from here to here, then you need to do the conversion from 5 degree to 9 degree here, okay? So we'll talk about that. So typically, if you want to convert from one scale to another scale, then you will pick two reference points, okay? The often picked ones are the freezing point of water and then also boiling point of water, okay? So if you take those two reference point, then you can convert from the two temperatures, okay? So here's the algebra. Let me show you the algebra on the conversion here. I think I have to stop sharing so then I can have the full screen mode here. All right. Where are my pens? Over here. So say if you want to convert from one scale to another, okay? So say if you know the temperature in Celsius, which for a science major, you are typically getting used to like Celsius, okay? So, and then you want to tell your friend at home, converting from Celsius to Fahrenheit. So let's say T sub F means temperature in Fahrenheit, okay? And then you want to convert from Celsius. T sub C means temperature in Celsius to Fahrenheit. Usually this should be a linear relationship. So that means this is a constant number. We call it A times this plus B, okay? Now the goal is to figure out what's A and what's B, okay? Then once you figure out A and B, then you have the conversion formula for converting from Celsius to Fahrenheit, okay? So now we want to know what's A and then what's B. Now, as I mentioned, usually you take 2 reference points. So for freezing water, freezing temperature of water, okay, it freezes at 0 degrees Celsius or 30 degree Fahrenheit, okay? So these are known facts, okay? So then you can put this into this formula over here because this is 32. So 32 degree Fahrenheit equals to a parameter A times 0 degrees in Celsius plus B, okay? So this is from the first reference, you can come up with the first equation, all right? And then from the second reference, when water boils, it's 100 degrees Celsius or 212 degrees Fahrenheit, okay? So then you can write a second equation. So this is basically the TF, this is TC, okay? So TF is 212 degrees Fahrenheit equals to A times 100 degrees Celsius plus B, okay? So then you have equation 1, you have equation 2, you have A and B to solve, okay? So from there, you can solve A and B, okay? So basically, you can take a look over here. From the first equation over here, this is 0, right? So then it directly will tell you B is equal to 32, right? Degree Fahrenheit. Now you have B here, you can take that into the second equation. You can solve for A, okay? So 212 degree Fahrenheit equals to A times 100 degrees Celsius plus 32 degree Fahrenheit, all right? So then you move this guy to the other side of the equation. So 212 minus 32 equals to A times 100, right? Degree Celsius here. This should be degree Fahrenheit on the other side. 212 minus 32 will give you 180 equals to A times 100 degrees Celsius. So that tells you, you divide both sides by 100 degrees, right? A is equal to 180 over 100 Fahrenheit over Celsius, or 9 over 5, okay? So that would be A, all right? So then, and then the units for this would be Fahrenheit over degrees Celsius, okay? So then you have A and B, so then your conversion formula is determined, okay? So then TF equals to 9 over 5, or if you want, you can say this is 1.8 because 180 divided by 100 is 1.8, okay? Times the temperature in Celsius plus B, or B is equal to 32, excuse me. And this is Fahrenheit over degrees Celsius, okay? You can drop the units, but at the end, you can put back your units, okay? So this is your name conversion factor or conversion formula, okay? To convert from Celsius to Fahrenheit. You can do the same for the other way around. If you want to convert from Fahrenheit to degrees Celsius, for example, if you have a friend from, say, from Canada or Mexico coming to visit you, and then he's confused with the weather forecast says today the high will be 40, then you can tell him what's that in Celsius degrees, okay? So then you'll set up like temperature in Celsius equals to, now let's use C, temperature Fahrenheit plus D, okay? You can use the same 2 references when water freezes and then water boils to write two equations, then you can determine what's C and D, okay? So I'm not going to repeat that algebra, but that's something you can do, okay? So knowing this could be very helpful when you travel to another country, okay? Like when I didn't know when I first came to the States, the weather forecast, it was summer, it says today the high will be 80. So I was very concerned because 80 in my country, that means 80 degrees Celsius, okay, which you can like cook something. So, but then later I learned, okay, it's 80 Fahrenheit, okay. I actually didn't learn that in school myself, so I was really kind of surprised, okay. But all right, so now you can do the same if you want to convert from Kelvin to Fahrenheit, or Fahrenheit to Kelvin, or Celsius to Kelvin. Okay, so doing the same technique here, write up a linear equation with two unknown parameters, and then use two references to write out the two equations. Okay, so these are the two references. So with that, then you can actually calculate temperature from one scale to another scale over here. So this is from Celsius to Fahrenheit. Okay, so you can write in this way or you can write in that way. So they are the same. Okay. All right. This is just the how you want to label it different. You can do like T parentheses degree Fahrenheit, okay, for the symbol. And then this is another way of doing it. Put a degree in the subscripts here to denote this is temperature in Fahrenheit, okay. But they are the same formula, okay, pretty much the same. And then from Fahrenheit to Celsius, now this is 5/9 times temperature in Fahrenheit minus 32, okay. And then put parentheses there to get to Celsius. From Celsius to Kelvin is simply just a adding 273.15 to the Celsius to get to the to Kelvin. From Kelvin to Celsius, you might subtract 273.15 from Kelvin to get to the Celsius. Okay, and then from Fahrenheit to Kelvin, basically this is doing like two steps. So the first one here is converting from Fahrenheit to Celsius and then plus 273.15. Okay, here what you are doing is converting from Kelvin to let me see, Kelvin to Celsius first, and then converting to Fahrenheit. Okay, those two steps. But these are the equations you can use, okay, to convert from one to another. All right, let's do an exercise over here. So the lowest temperature on Earth was reported as minus 89.92 degrees Celsius on that day, July 21st, which I believe none of you were here at that time. I was only like 3 years old. All right, anyway. So let's see how much is this in Fahrenheit. Okay, so give it a try, see what you get, and then we can take a look at the solution together in a couple of minutes. So if you have your answers, you can click on this. It will bring up the link where you can submit your response, okay? Something like this, and you can type your answer here and submit.
Dr. Ho,
Yes.
do you care what decimal place it's put in, like the tenths or the hundredths for the answer?
All right. So I got a question from online says how many sig figs do we keep? Okay. So on this problem, the number given shows like 3 sig figs here. So your answer you can just keep up to 3 sig fig. Okay. All right. And then usually I think if you keep 3 sig fig, it's pretty safe. Okay. Because then you have say 3 digits here, then the variance you got from the last digit will be contributing to like about one or two thousandths error, right? It's like 0.1% also. So then it's very safe. Okay. So if you have 2 digits, then usually it's or the uncertainty is like 1%. Okay. If you have 3 digits, then uncertainty is 0.1%. Okay. So that's pretty accurate. Okay. If you are in expert TA, if you can keep 3 sig figs, then most of the time you should be safe. Okay. But for example, it's like 0.0, if it's 0.01, then it's only 1 sig fig, right? So you can keep up to like 0.01, say 111 or whatever. All right.
Thank you.
All right. Okay. So I think I got quite a few responses in already, and then let me have a double look on here. Yeah. I believe all of your responses are very close to, or they are the right answer here. So basically, you need to use the equation, one of the equations in the table that you are converting from Celsius to Fahrenheit. Okay, so then what you need to do is use this equation over here from Celsius to Fahrenheit. Okay, so what you can do is just write down your equation here because you want to convert from Celsius to Fahrenheit. So 9/5 times TC plus 32, okay? At this point, it's very safe to just leave out the units, okay? And then you can put the units back at the end. So 9/5 times minus 89.2 plus 32, okay? that will give you minus 128, I believe 128.56. But that should be in Fahrenheit. Okay, so you can keep 3 sig fig to minus 129 Fahrenheit. Okay, all right. So so you guys knew already last semester, if in expert TA, it doesn't care about how many sig figures numbers, okay? As long as you keep more than 3, then you should be pretty good, okay? You can keep more, you can keep 4 or 5, it doesn't care, all right? And then in the exam, usually you are just having non-multiple choice problems, so you don't have to worry about how many sig figs there, okay? But when you are doing your calculation from steps to step, you might want to keep up to like 3 or 4 digits to be safe, okay? All right. So this is the exercise on this one here. Let's move on here. So in the olden days, all right, people use a device called gas thermometers, okay? So it's something like the figure here. So you have some kind of liquid over here. So typically people will be using mercury over here, all right? And then this is the water bath, or you could have some other baths like sand bath, or I think the most convenient one to have is water bath. You can heat the temperature of water or heat the water. So when it gets hotter, then the temperature is higher. When it gets colder, then temperature is lower. All right. You can monitor the differences of the two levels on the tubes here on this side and this side of the mercury. So if these two levels are bigger, that means you have more pressure here in this gas container over here, which is corresponding to larger temperature or higher temperature. Okay, so the temperature is indicated by the pressure here, or the height difference on these two surfaces here on the two sides. Okay, if you have, and then you want to keep this one at fixed over here. So basically this is kept at fixed level here, but this one can change. You can move this guy because this is flexible too, okay? So then by doing that, by doing some measurement and calibration, you can have a gas thermometer like this, okay? You can put scales on here, then you can tell, you can say like 20 degrees here, maybe 10 degrees here, or whatever corresponding scale, okay? So by looking at this gas thermometer, people were able to count up like temperature ranges, okay? So the one thing that people figure out is that it's actually very difficult to reach a low zero or low limits on the temperature, or 0 degrees in Kelvin, okay? So what happens is here, you have temperature here, and then you have pressure here. So as I said, if you increase temperature, your pressure will increase. So you can have different gases in the container, and they will respond to the temperature differently, okay? Because different gas molecules, they actually, we'll talk about it later, but as temperature increases, the movement of the gas molecules, they will have different speed, okay? The higher temperature you have, the higher average speed you would have for the gas molecule. And then when you have higher speed for the gas molecule, that means it will hit the container wall more frequently, and then gives you more pressure, okay? So, but you also have to take into account the gas mass, okay? So this is because different gases will have different masses, so then their slope is a little bit different, or the pressure they can produce is a little bit different, okay? We'll take a look on the detail later, but here is what you see is if you have different gases experimentally wise, now you can go as temperature increases, the pressure will increase. But as the temperature decreases, which when you go to lower temperature, the lower temperature is very difficult to attain. Okay. Now, in the lab these days, I think you cannot reach to the lowest you can reach is very close to 0 degree Kelvin, but not zero. Okay. So you can back extend the line so you can predict, okay, where will they meet here. So it turns out they all meet at least one point, okay. Back in the days, people use Celsius. So they figure out this at this point when they all these lines meet, it will be at minus 273.15 degrees Celsius, okay. So then they define this as absolute zero in Kelvin. Okay, so this is how Kelvin is defined. So it's this guy minus 273.15 degrees Celsius. Okay, so that's absolute zero in Kelvin. All right. So then in that case, from Celsius to Kelvin, simply you just add 273.15 to Celsius to get to Kelvin. Okay, or the other way around, you subtract 273.15 from Kelvin to get Celsius. All right. Experiments also reveals that you can go very high temperature, so there's no limit. The highest we know so far is about 10 to the 12 in Kelvin so far. Okay, and then you can go to, so this is the lowest we have, like 10 to the minus 10 degrees Kelvin so far. But in the lab, you can still cannot go further than or smaller than 10 to the minus 10. For example, 10 to the minus 11 is not possible to get, okay? All right. Now, the last example I would like you guys to work on is this one here. So our normal temperature, body temperature, human body temperature is about 98.6 in Fahrenheit. So if you go to another country and then unfortunately, if you feel sick, you say you had a fever, then the doctor will ask you what's your temperature? You say 98, or you say 100, maybe they wouldn't understand. Okay, so you need to tell them what's that in Celsius. Okay, so first figure out what's the, or let's figure out what's your normal body temperature in Celsius. Okay, and then later on we can do that in Kelvin. All right, so most of you guys have responded here. And then I think most of you guys got this one right, except one. But basically, so this is converting again from, now this time you are converting, for part A, you are converting from Fahrenheit to Celsius. Okay, so you do T sub C equals 2. You get the formula from the table, 9/5. This time you do T sub F minus 32 first. Okay, so remember, if you are doing from Fahrenheit to Celsius, you subtract 32 out of Fahrenheit first and then multiply by 5/9. Okay, so this would be 9/5, 98.6 minus 32. Okay, that will give you 37 degrees. Okay, we can keep 3 sig fig because this one is given as 3 sig fig. Okay, so that's that one. On the second one, you are converting now to Kelvin, so this will be easier. From Celsius to Kelvin, you just add 273.15. Okay, so basically 37.0 plus 273.15, that will give you about 310 Kelvin. Okay, it should be 310.15, but you can just keep 3 sig figs here. All right. So sometimes when people write the, I think I forgot to mention here, sometimes when people write the units here, so typically you can do like a subscript 0 over here, a superscript 0 here, and then C, okay, for degrees Celsius. Some people like to write as 370.0 Celsius and then put degree here after the C, because if you put 0 before here, some people may be misreading as 37.00. Okay, this is not a problem, but when you have, say, 310 degrees Celsius, it could be misread as 3,100 degrees Celsius. Okay, so that's why some people prefer to write the degrees after the letter C. Okay, if you see that in some of the textbook, that's the reason there. Okay, but otherwise, I think it's pretty clear there. Okay. All right. Any questions you guys might have before I let you guys go? All right. If not, then we'll see you guys in lecture on Friday. Okay.
Thank you.
Thank you.